Ladies and gentlemen, nerds and cool kids, welcome to today's episode where we explore the marvelous and fascinating world of music and mathematics. Now, buckle up and prepare to have your minds blown as we dive into the symphony of numbers and the calculus of tunes. You know, music and math have been intertwined since the dawn of time. And no, I don't mean when the dinosaurs roamed the earth, headbanging to some prehistoric rock. I'm talking about the ancient Greeks who realized that the beauty of music lies in its mathematical patterns. Pythagoras himself dabbled in this cosmic dance of melody and numbers, discovering the harmonic intervals by stretching strings across a monochord. But let's fast forward to today, where we are still uncovering the hidden secrets of this magical relationship. Have you ever heard of fractals? They're these infinitely complex patterns that repeat themselves at different scales. Much like the hair on a bad hair day, they seem chaotic at first glance, but they're actually governed by mathematical rules. Now imagine that, fractals in music? You bet! It's like listening to the audio version of the Mandelbrot set. Composers like Bach were known to create musical fractals, where a theme is repeated at different levels, giving the listener an auditory déjà vu. The fugue, a polyphonic composition technique, is a perfect example of this intricate balance between repetition and variation, melody and mathematics. Moving on to rhythm, we find a beautiful playground for mathematical patterns. From the simple 4/4 beat to the complex polyrhythms found in African music, we can observe an interplay between arithmetic and creativity. Let's take the Fibonacci sequence, for instance. 1, 1, 2, 3, 5, 8, 13, and so on. When translated into rhythm, we can create intricate and catchy beats that resonate with our innate mathematical sensibilities. And what about symmetry? Much like a butterfly's wings or a perfectly sculpted mustache, music exhibits symmetry in many forms. Melodies can be flipped, mirrored, and even rotated to create new and exciting variations. The famous palindrome canon by Haydn, Symphony No. 47, is a brilliant example of musical symmetry at its finest. Speaking of symmetry, let's talk about the circle of fifths. For those of you who don't know, the circle of fifths is a geometrical representation of the relationship between musical keys. Picture a clock with 12 hours, but instead of hours, we have keys, and instead of minutes, we have, well, nothing really, it's just a circle. But this simple circle holds the secret to harmony and chord progression that has tickled our eardrums for centuries. Now let's not forget the unsung hero of the music math love story, the humble waveform. Without the sinusoidal waves that vibrate our eardrums and travel through the air like a musical Cupid's arrow, we would be left in a silent and mathless world. The Fourier transform, a mathematical tool used to break down complex waveforms into simpler sine and cosine waves, allows us to analyze and understand the very essence of sound and harmony. So whether you're a head-banging rock fan or a classical music connoisseur, remember that every note you hear and every beat you tap your foot to is a testament to the unbreakable bond between music and mathematics. They are the yin and yang of human creativity, two sides of the same coin, forever intertwined in a cosmic dance that brings joy, emotion, and understanding to our lives. Thank you for joining me on this melodious and mathematical journey. If you enjoyed this deep dive into the world of music and math, be sure to give this video a thumbs up, subscribe to the channel, and hit the notification bell to stay updated on all things music related. So keep in mind the beauty of numbers and the harmony of equations. And remember, when you listen to your favorite tunes, you're not just grooving to the beat, you're also celebrating the fascinating world of mathematics. Until next time, keep your ears tuned and your calculators handy, and let the music of math guide your steps through the symphony of life.